Hello, this is Romain from the Code and Coders team. In this video, we will explore the different steps on how to code the basics of a presentation engine using Compose Multiplatform. Let's go! Okay, so let's start with a simple Compose Multiplatform project with some custom material theme with our brand colors and font, which are loaded through the Compose Multiplatform resource mechanism. And we also have a unique composable that represents the content of our Compose Multiplatform application, which is a kind of a introduction slide. So here it is. You probably see that the composable elements, so the text, images, are not taking advantage of the full window size. So this is not a problem here, but in presentation context, your audience may have some difficulties to read the content of your slides. So let's start by addressing this problem. So let's create a container that will be responsible for managing and adapting the density of the presentation. So the beauty of Compose is that we don't have to rely on the client screen resolution, as using the density, Compose will automatically transpose your dimensions, so DPs, SPs, etc., to pixels. So let's start by retrieving this density from the composition local mechanism. And now we can simply override this density by using the composition local provider and by providing a new value to this density. And here we will apply a scaling ratio to it so it can adapt the content of the presentation. So how do we compute the scaling ratio? We will need two things for that. The first thing is that we need a target size, which represents the aspect ratio on which we want our presentation to be adapted to. So here, this is a 69 ratio. And the second thing is that we will need to track the presentation container size. So here we will use the onSize change modifier functions to keep track of the box size, and we will put it inside a mutable variable. And now we are able to compute our scaling ratio. So what happened here is that every time the presentation size change, we will calculate the product of the presentation sizes by the target sizes, and we will keep the minimal value to ensure that the ratio respects the window size, so our presentation shouldn't go outside the boundaries of our window. All right, so let's apply this container to our application and let's run it. All right, so now you can see that our composable elements are taking up to the maximum space inside the window. And if I resize the window, we can see that the composable elements and the presentation itself is automatically adapted and the ratio, the 69 ratio, is kept. So now that our presentation is well displayed, we can start building our speaker deck. So let's start by adding a new structure that will be responsible for all identifying the slides and obviously holding the content of each one of our slides, which will be a composable lambda. Now I can migrate my introduction slide as a variable of type slide, which is named intro, and the content remains the same. I can enhance my presentation by adding multiple slides. So let's add an agenda slide, which is a column with some text. And let's add a conclusion slide, which is also a column with some different text. All right. So you're probably aware of how Compose works. One of the ways to trigger a recomposition is to monitor or observe some kind of observable state. So let's create a new class that is a presentation state that will hold all of our slides so we can iterate and display them. And we will obviously need a current slide index, so we can define or track on which slide we are and which one we need to display. So let's instantiate our presentation state inside our presentation. So we will need to add some slides as a function parameter. And now I can simply display my current slide content. And obviously I need to pass my slides to my presentation. All right. So if I run the app, this will probably work. But we will just end on the first slide of our presentation. And what I expect from a speaker deck is to be able to go forward and even backward on the railway of my wonderful slide. So let's start by changing the presentation state to reflect that. So we will need to move our current slide index as a private set variable, so only the state itself can modify it. And we will need to implement two functions, a go to next function to go to the next slide, a go to previous to go to the previous slide if there is some. So let's start by implementing the go to next. So if my current slide index is lower than the last index of my slides, I can go forward. If not, I do nothing. And if I am not on the first slide, I can go backward. Sounds easy, right? So now all I have to do is to bind those functions to something like a key event handler. So let's go to the main function and let's define a key event handler at the window on the window level, as it is the way we declare key event handler with Compose Desktop. So here I intercept my left and right arrow keys on my keyboard. And what I expect is to be able to call something like a state with my go-tos functions. But you probably see that this is something that is not possible, as there is no state reference yet here, as our state is defined inside the presentation. So obviously I will need to create my state inside an upper scope. So let's assume that our window is wrapped in something like that knows about the state, and let's encapsulate our window in it. So now we should be able to call our goTo's function, and what remains is to implement our composable function that takes a composable lambda that itself receive a presentation state. So now I can instantiate once again a presentation state that needs some slides, a list of slides, and I just have to call my content with my state. All right. Now I can pass my slides to my wrapper function, and we are done. One last thing is that if I need to consume or display my presentation, I will need to pass my state reference to every composable children. So let's change our implementation so we can just consume our presentation state with something like a composition local that can provide our presentation state across all our composable tree. So let's create our composition local and just provide our state here, and we can now just remove the presentation state from the content lambda and adapt the call site to consume the composition local.current. All right, now we can also adapt our presentation to remove the presentation state initialization and replace it with a local composition local consumption. And if I run the app, I expect it to work. All right, so our application is running, but I am hitting my keyboard and nothing's happened, so I cannot navigate. So what did I do wrong here? This is probably the guilty one. So here the presentation state is not considered as stable by the Compose compiler nor the runtime, and there is nothing observable. So there is no way our recomposition is triggered when changing the current slide index. So let's update our variable declaration by using the mutable state of function, and let's rerun the app. Yay! So we can now navigate through our slides. Okay, so this is maybe not as appealing as any solution you may be used to, but it's a start. Now we can enhance our presentation by adding transitions between our slides. So let's do that. So how do we animate our transitions? We firstly need to iterate through our slides with the key functions that will help Compose optimizing its recomposition cycles. And we can display the slide content with some animations. So here we will animate our content when the index is equals to the current slide index. Furthermore, we can also add some custom animation. So we will add fade and slide animation to the enter and the exit animations. Okay, so before we used Clinics HTML and Compose HTML to declare our slide or speaker deck. We had difficulties animate things because we had to use HTML and CSS, and we were limited by CSS. Here, we just have to use a few lines of code, and we will have smooth and efficient animations. Let's see what it does. Yay! So this is working, but as you can see, my slides are all coming and go to the left. So what I want is to have some kind of mental visualization of my slides like a railway. So I want them to come from the right and go out to the left. So let's change our presentation state for that. We'll need to add a forward Boolean value. And obviously, if we are going forward, it's true, and otherwise we can set it to false. And we can adapt our animation to use this value. So here, if I am moving forward, I want my slide to come from a positive offset, so from the right. And if I'm going backward, I want them to come from a negative offset, so from the left. And we can invert this behavior when exiting. And let's see how it works. All right, nice. Okay, so one last thing. We are almost done here, but a slide is of no use if we cannot have some multiple steps in it. So usually we have some titles, some bullet points, some element list, and we like to animate our elements so they can appear one after another. So now we can change our slide presentation. To do that, we'll need to handle a step count inside our slide structure. So it defines how many steps a slide can have. And obviously we need to pass a current step index to our content so it can behave accordingly. Now we can adapt our slides. So our intro slide will not need multiple steps, but we can add multiple steps with some animation with our agenda slide, for example. Here we can add some animated content. So here, if my step is higher than 0, we will display this column with some animation. And let's add more steps to our conclusion slide with some animated content as well. So here we will have 2 animations depending on the timeline. All right. Finally, we need to adapt our presentation state to handle that current step index. So we will need to declare a mutable value for handling this step index. and we will need to adapt our goTo's functions when it is relevant. So here, when the step index is lower than the current slide step count, we can go to the next step. Otherwise, we try to go to the next slide. And in that case, I need to reset my current step index to 0 so I can land on the first step on the next slide. And conversely, I need to define the backward behavior. So when I'm not on the first step, I can go to the previous step. Otherwise, I try to go to the previous slide. And here as well, I need to reset my current step index so I can land on the previous slide last step. So to have some kind of proper navigation. All right. And lastly, we need to pass our current step index to our slide content, and we can see what it does. Nice. Now I can go back and forth with some smooth and efficient animations. So let me know in a comment, what do you think of it? All right, that's it for today. These are just the basics, and from these basics, we created a full-fledged Compose Multiplatform engine. Click on the link that now appears on the screen to learn more and start programming amazing slides with Compose Your Prez.